Alright guys, we're starting off our unit with points, lines, and planes. So we're starting with the basic building blocks of geometry. Now I do want to point out that these three words, points, lines, and planes, are oftentimes called undefined terms. Basically, there are building blocks, so we just give them a description and we paint a picture with them. Anything else after that is defined because we can use points to build stuff, we can use lines to build stuff, and we can use planes to build stuff. But whenever you see the term undefined terms, know that I'm talking about one of these three things, either a point, a line, or a plane. Once again, if you're on an assessment and ask for undefined terms, hint, hint, you're going to look for points, lines, and planes, and that's it. Undefined terms means points, lines, and planes, and that's it. Let's start with the most simplest geometric shape, and it really isn't a shape because it's, if we look right here, it's our point. It is really just a location. It has no size. Now the thing is, we can't see something that has no size. So if I want to point to a location, I have to do something. So what we do is we actually draw, and for lack of a better word, we draw a point. We need to realize that that actually has no shape, but to make it bigger so we can see it, we actually make it bigger so we can see it. So we put a point, and a lot of times we'll see a capital letter next to that point. Let's put a capital letter P by it. That is known as point P. In fact, that gets us to our notation. Our notation for this point would be point P. And we always use capital letters. So that might have been point, I don't know, B. It could have been point A. It could have been point C. As long as there's a capital letter by it, that is the name of that point. Now remember, these are names. They're not variables. They are names for these particular objects. Now, when we build up, we're going to build up to a line. Now, if you ever draw 2 points together, you can always connect them into a straight line. Now, in geometry, when you talk about lines in art or some other class, you might think this is a line. Well, in geometry, we can't have any curves. A line is actually a perfectly straight shape. And to add something to that, that is not, in fact, a line. To be a line, it has to go forever in both directions. So we need to put arrows on both sides of this to actually make this a line. We're going to learn later on that this is actually a line segment. It's part of a line, but when you put the arrows on, it's the entire line. Now let's go back to what's written up here. What's written up here is it's an infinite number of points. So that's the first thing I want to point out is it's an infinite number of points. Now a lot of times people think a line doesn't have any points in it. But if you zoom in, if you zoom very, very far in, you're going to realize that a line is actually made up of an infinite number of points. I'm trying to represent that with these points here. Obviously mine are limited, but it's unlimited. It's an infinite number of points that actually make this line up. I'm going to go ahead and erase those real quick. So a line is an infinite number of points just stretched in a straight line. Now they go on a path that extends in 2 opposite directions. That's why we have those arrows with no end, and it has no thickness. So we can't see something with no thickness, so we do have to give it some thickness to visualize it, but we need to realize that it actually has no thickness. It just goes left and right, and that's it. Now, when we name these, there's 2 ways to actually name these. The first way is sometimes you'll realize that there's a little letter next to it. So let's go ahead and put a letter L, a lowercase l. Sometimes I use a cursive L. You can use whatever L you want in this case. So I'm going to go with my cursive L. Now, the notation for this line would just be, hey, tell me you're looking at line L. And I know what line you're talking about. You're talking about the line with the L by it. Now, oftentimes we won't have that letter there. Instead, what we'll do is, remember, this is an infinite number of points. We'll pick 2 points out, and we'll name them just like we named that point P. We'll use a capital letter, we'll use A, and we can use any letter we want, but just for semantics here, we'll use A and B. Now, if I want to use those 2 letters, we're actually just going to say AB. Now remember, these are any two letters that are on here. So if there was another letter on here, say we had C on here, I could pick C as well. We could call it AC. I'm going to go back to just the A and B. Now, AB actually means something different right now. What we need to do is we actually need to draw a line above it. And that tells you you're looking for line AB. Now, we can also switch the letters. So another way we could rewrite this is we can call this line BA. Doesn't matter which order it goes in, we draw the exact same line. If I say look at line BA, we're still looking at that exact same line. Nothing would change. Order doesn't matter when you're looking at a straight line. All right, that's it for lines. Now we're going to get to a very difficult concept, and that is a plane. Specifically difficult because a lot of these drawings are going to be in 3 dimensions, but it's on a 2-dimensional sheet of paper. So it can be really hard to kind of picture. So if you're homesick, make sure you come and get help on these and how to visualize it 3-dimensionally, because we do have a lot going on there, particularly in that second picture. Well, that first picture there, that blue one I have there with those red arrows, is actually a plane. Now, a plane is an infinite number of points and lines on a flat surface that extends without end and has no thickness. So here's my advice to you. When you picture planes, you can think of a wall or a floor or a ceiling. If we picture this blue thing as a floor, let's look at your floor right now. Now, it looks like it's a rectangular shape. However, you need to realize that this thing actually goes on forever. That's what these arrows stand for. Now, we're not going to keep writing a bunch of arrows over here to tell everyone that it keeps going on forever. You just need to find a way to figure out that this shape goes on forever. This direction goes on forever. This direction goes on forever. So it goes on and on and on. So it's a floor that never ends. Or it's a wall that goes up forever, goes down forever, goes left forever, goes right forever. That's going to be key because if we look at this next picture here, it looks like it's just a rectangle. It looks like it's just this shape. But we must realize that it goes forever in these different directions. Now, the other really complicated thing about this drawing is I'm going to bring to your attention, we do have this plane. Once again, it goes on forever. Now, the next thing I want to look at is this line. This line is actually laying flat on that plane. So that line is on the plane. If you picture your wall and you drew a line on that wall, that line would be on the wall, along with the points E, F, C, and A. All of that is on that plane. It's just lying there. Now, the next thing I do want to point out is this line here. This is where the 2 dimensions comes into a problem with 3-dimensionals. This line right here does not lay on this. It actually stands up vertically. Think about if you had a piece of paper and you jammed a pencil through it. You jam a pencil through it, half your pencil's above the paper, half your pencil's below the paper. So if you look at this line, that green arrow is actually sticking straight up from that plane. Down here, that's why we have those dashed lines. Doesn't really work with my green. I'll try to simulate that. That means this is actually shooting straight down from the paper. So this line actually goes through the plane. It doesn't lay on top of it like that EF line does. So it goes straight through it. So if you look at the point B, that's actually above that plane. That point D is actually below that plane. So we're going to have to keep that in mind when we get to this next thing, and that's notation. Well, one of the easiest ways to note a plane is to find a letter that's not actually on a point. So if you look at this X, and it's almost always in one of the corners, that X is not signifying a point. It's actually the name of the plane. If you look at any other point, it's got a point along with it. The X does not. It's just all by itself in that corner, so that's his name. So we can call this plane X, just like we could call this line L. Now, oftentimes that X doesn't exist, so there must be another way to put what kind of plane we have. So if we look here, let's go back to point. Point, we use one letter. Bam, we got point P. When we have a line, we use 2 letters. So it makes sense that when we have a plane, we're going to use 3 letters. So we are going to use 3 letters. We just got to figure out which letters to use. So the first rule is, in order for it to be part of the name, it must be actually on the plane. So I'm going to go ahead and get rid of 2 letters. I'm going to get rid of B and D, because B is way above the plane, D is way below. We said that C, F, let me change my color real quick. We said that C, F, E, and A are all on the plane. Now, we can use those 3 letters. We got 4 of them to pick from. We have to use 3 of them. We can't just pick any 3. And before we decide which 3 we need to pick, we actually need to get to the next concept, and that is collinear. So I'm skipping down to this collinear section real quick, and then we'll go back up to naming that plane. Collinear is just a fancy word to mean these points are on the same line. Now, I do want to bring your attention to this note here. If you can draw a line through the points, they are in fact collinear. So that means if you can draw a line through the points, they are collinear. So I'm going to give you an example here. Now, if you picture those 2 points, you can picture a line going through it. There's a rule with collinear points that any 2 points are automatically collinear, because picture any 2 points you put on here, you can draw a line through it. The key is going to be that 3rd point, or the 4th point, or the 5th point. Where I draw that 4th or 5th point decides whether it's collinear or not. So 2 points, automatically collinear. The 3rd point, I'm going to put it right here. Now, we don't have to draw a line through this to know it's collinear. We just have to kind of picture that a line could be drawn through it. If a line can be drawn through it, it's collinear. If you can't draw a line through it, it is our next word, which is non-collinear. Non-collinear would be like this. Once again, 2 points, collinear. It's that 3rd point, let's put it up here, that now it's no longer collinear because I cannot draw one line through both of these. I can either draw a line through these 2, or I can draw a line through this one. These are not collinear because I can't just draw one line through both or all 3 points. All right, so we have collinear, non-collinear. Let's go back up to the plane and how to name a plane. To name a plane, we said we need 3 letters. I guess I could probably, let's do this. Let's go 1, 2, 3 letters. Those 3 letters have to be non-collinear. So they can't be all 3. So we cannot pick E, F, and C. Those are 3 collinear points. So instead, let's pick E and F. Now we can't pick C because that would make a straight line. So instead we're going to pick A. E, F, A are non-collinear points on that plane, so that would be the name. Maybe getting rid of these lines real quick, just so we don't normally write that. We would have E, F, A. We could also have ECA. We could have FCA. The only one that wouldn't work would be EFC because that's 3 points that are collinear and it needs to be non-collinear points. So once again, either it's a name plane X or you pick 3 points that are not collinear. All right, the next thing we're going to get to is coplanar points and non-coplanar points. We said collinear points, you can draw a line through it. Non-collinear, you can't draw a line through it. So this must be the same idea. So if it's coplanar, you can draw a plane through those points. So if we look at this drawing, now once again, I want us to picture that this is actually a vertical plane. This would be like a wall. Once again, it goes in every direction. But picture your wall right now. Now picture you drew a line on that wall along with these points A, B, C, and F. So A, B, C, and F are all on one plane. Now let me erase that real quick because let's bring out the next part. It's that line. I'm talking about this line right here. This is like if you're looking at your wall right now, there's a line coming right at your face. It's going through that wall, and the only point that touches the plane is that point right there. Okay, so that's coming at you. Everything else is on the plane. So what would make this collinear? Points on the same line. So coplanar points for this one would be A is on a plane, B is on the plane, C is on the plane, and F is on the plane. All of those are coplanar. Non-coplanar, we got to be careful with non-coplanar. To make non-coplanar points, my idea to you is pick 2 points. Now, I'm going to pick really weird ones because you're probably like, well, let's pick A, B, C, or F, and then pick E or D because we know they're not on the same plane. But I'm going to do something different. I'm going to pick A and E. And you're going to look at A and E, and you're going to say they're not on the same plane. Well, to be coplanar, it just has to be, can you draw a plane? So if you look at A and E, if I draw a picture like this, that's a plane. I drew the plane, that's fine. That just means A and E are on this same plane. Now remember, this plane goes down, left, up, right. So this plane consists of points A, B, C's on it, E's on it, and if we stretch this all the way over here, D is also on it. So this is basically, if you have a wall, you have another wall cutting through halfway through it. The only point that's not on this plane is actually going to be F. So that means A and E are on this one plane, F is on a different plane. So A, E, and F are non-coplanar. A, E, and F are non-coplanar. Once again, this is really hard to picture in 2 dimensions. So please come see me and we can talk through it with more 3-dimensional objects. All right, next thing we're going to talk about intersections before we get to line segments and rays. Intersecting lines. So intersecting lines are just 2 lines that happen to intersect. Now, the intersection of 2 or more geometric figures is the set of all points that they have in common. Well, 2 lines, when they intersect, only have 1 point in common. That's right here. This intersection is just a point. So if I ask for the intersection of lines, you're just going to give your answer is a point. Now when planes intersect, a good way to picture planes intersecting is picture your wall and your ceiling. And look at what they form. They form a corner. Well, that corner runs forever left and forever right, because as a reminder, planes go forever. So if you look at these intersections, they're intersecting on this line right here. So the intersection of 2 planes is always going to be a line. 2 lines intersect at a point, and 2 planes intersect in a line. Now let's go ahead and break some things apart. Now, if you remember, I said undefined terms include points, lines, and planes. That's it. Just need to know those 3 things for undefined terms. These are all defined because they're based upon those original lines, points, and planes. So when I say undefined terms, we're not talking about line segments. That's actually defined. So we have a line segment is a portion of a line with 2 endpoints. Well, before we get to a segment, let's start with what we learned last time. So if I asked you to look at that picture and give me a symbol for line AR, that's what it asks here. Well, a symbol for AR, well, there's no lowercase letter to name that, so I'm just going to go, I'll just put AR, and I'll put a line above it, so everyone knows that I'm talking about this entire line. Now, that might not be how you named it. Actually, lines can be named with any 2 points found on that line. So AR is actually the same thing as line RA, because that would still be that red line there. In fact, I can pick out any 2 points on the line. So I could pick out, as weird as it seems, I could pick BR. Those are 2 points on the line, because if you picture BR, let's erase this real quick. BR almost looks like that line there. However, the arrow says that means it covers all of this. So BR would be the exact same line. So would NB, so would BN, AN, NA, any 2 points create the exact same line. The only letter we can't use is P because it's not on the line. All right, so a line that contains the points A to R, anything before A, and anything after R, and the endpoints A and R. All right, now we're going to get to the new thing, and that's called a segment. A segment is just like a line, except it doesn't have arrows on the ends. To use a segment, so let's talk about AR. So if you look at my drawing over here, AR would be that red section there without the arrows. So in other words, AR would look like this. Now note, losing those arrows changes a lot. So we don't have arrows. So when we're naming this, we're actually going to name it AR without arrows on top of it. That's how you do the label for AR segment. I do want to skip 3 of these. So AR is going to be the exact same thing as, let me erase this red thing real quick. So I'm going to skip to this is the same as RA. Because if someone asked me to draw the picture of AR, I would just fill in A, fill in R, and connect those 2 sections. If someone asked me to draw the segment RA, I'd fill in R, I'd fill in A, and I would connect the segments. I didn't change anything. However, if someone asked me to A and R, and I filled in R, and I filled in B, and I filled in this section between, I'm missing a big chunk of it. I'm missing all of this because there's no arrows to cover that up. For lines, we had arrows that went forever. Segments end. It starts at R and it ends at B, which means I'm missing all of the points from B to A. So AR is not the same thing as BR. It is not the same as, I don't know, NB. It is not the same as AN. When you're using segments, you must use the end points. That's key. For lines, you can use any 2 points. But for segments, you have to use the endpoints. All right, the last thing I have in this little section is called distance. What's the distance from A to R? Now, distance is if you just took a ruler and actually measured from A to R. To do that, we're just going to put no symbol above it. So that's perfect right there. It's just plain old AR. That tells you measure the distance from A to R. That would be the same as measuring the distance from R to A. If I got a ruler out and started at A and went to R, or if I started at A and went to, or R and went to A, I would have the same distance. But just like segments, these must use endpoints. Endpoints. All right, the last big concept we're going to cover is we're going to cover rays. A ray is a part of a line that consists of one endpoint, so it has one endpoint, and all of the points on the line on one side of that endpoint. So a ray, in essence, is going to look like this. It's kind of a combination of a line and a segment. It has one endpoint and one arrow. So if we look back at the drawing, we're supposed to find what's the symbol for ray AR. So let's go back to our drawing. We want ray AR. Ray AR would be this drawing here. Note it starts at A, but then it goes forever in that direction. So if I want ray AR, we have to be careful how we name it. Your endpoint comes first, and your arrow side comes second. And we make sure we draw a ray above it. But because this is our end, that A has to be the endpoint. R isn't as important, but that endpoint is. For instance, AR is the symbol for ray AR. But we could have also done AB. Ray AB would have been the exact same ray because that arrow would carry on. AN would also be the same ray as AR because that arrow carries on. However, if we mess up the endpoint, it's not going to work. So ray AR would not be the same if it has a different endpoint. So let's pick N. Oh, I jumped back somehow. Let's go back. So let's pick N. So let's say N to R isn't going to work. And you're asking me maybe why doesn't that work? Well, let's go back here. So we wanted A to R. I want that red line. if you just did n to r, that means it starts at n, that green dot, continues forever in that direction. That does not have that red section I have right there. So a to n is missing. So ray nr is not the same as ray ar. So be careful with your endpoints. So ray is just the points a to r and all the points after it. All right, the last thing we're going to talk about are opposite rays. These are rays with the same endpoint that go in opposite directions, i.e. opposite rays. So here's an example of an opposite ray. So that's a regular ray. If I just attach another ray to it, it goes in that direction. So they share this endpoint, let's call it P. Since they share that endpoint and they go in opposite directions, that would make it opposite rays. So if I look at NR, I'm looking for an opposite ray of NR. Let me erase this real quick. So it says, find the opposite ray of NR. Well, an opposite ray of NR would still have to start at N, but go in the opposite direction. So that ray has an endpoint of N, and it goes past A. So if we go back here, NR would be the same thing as, or the opposite ray of start at N and go over A. I'll note that it has to have the same endpoint. So if you say NR and let's say, I don't know, BA. Let's look at BA. So let's go back real quick. So I have NR and then you tell me BA is an opposite ray. I'm going to say they don't have the same endpoint, so they can't be opposite rays. So an example of something that aren't opposite rays would be NR and BA. Sure, they go in opposite directions, but they do not have the same endpoint. All right. That is our first lesson in geometry. I do want to note that you kind of have two assignments. After this page comes 2 pages, so 3 and 4 you got to complete. And also make sure to get online and do those quick Alex questions. I think there's about 5 today. Make sure if you're struggling with Alex logging in, you come see me. All right, good luck with the homework. I'll see you when you get back.